Hi, my name is Saqib Aziz. I'm a research associate at the University of Arts in the Department for Structural and Computational Design, also called KRT, and I will be presenting or giving a quick overview of the paper Designing Intuitive Experiences for Responsive Architecture, and this is a collective work that I've been doing with my colleagues, which are also mentioned in the paper. This paper is rooted in the new technology and advancements regarding human-machine user experience or interface design. We have been doing some pre-studies, exploring new technologies and ways to communicate with your built environment, and also how to propagate your design ideas to the means of robotic fabrication, etc., to create a more real-time link between design, thought, and actual fabrication in a real-time responsive loop. So two things that we explored. One was we were invited for the Seoul Biennale in 2017. We explored robotic fabrication and sound as the means of creating geometry. This was an installation built over 5 days, and you would speak into a microphone, your voice would be translated into geometry, as you can see here, and then in real time the robot would, through the means of hot wire cut, create the piece, and one would go to the wall and the other one would be gifted to the visitor. So you can see over the 5 days, people have been building up this installation with their voices, and collectively we have done an art piece. Now this whole idea of the human-machine collaboration, we took one step further for the pop-up factory 2019, exploring same routines, but looking also into augmented reality, building holographic interface to navigate our design and fabrication processes, looking at direct link and controlling the robot, and by the means of holographic interfaces, as you can see, and also having kind of a guidance for assembly. So looking at augmented reality to assemble basically what we have designed a few seconds before. The big question now is, how do we take all of this information and actually make it applicable for academia? This, of course, poses an even greater challenge with the COVID-19 pandemic and the need to commute to digital learning methods. One promising trend here are new e-learning platforms. We teamed up with Design Upgrade, an e-learning platform geared towards learning and development content for the AEC industry with a focus on interoperability between design and simulation software, to create a computational design class teaching the fundamentals in designing, programming, and fabricating with and for the Arduino interface. This allowed the students to learn the needed skills on demand and decentralized, and then test their learning in a hands-on workshop, allowing to create their own unique interpretations with the pre-designed kit of parts. Here's a quick video showing the workshop itself. The workshop was held over the course of 3 days. In the first day, we just did a recap of the online course, getting back everybody on track to understand how the module themselves are built up, looking at the individual parts that were 3D printed and designed in the course also. And then the task was first to assemble those pieces that we have learned in the online course, looking at also the mechanics that is based on a pistol mechanism to push and pull those individual 8 blades, as you can see here. Then we looked also at how to program those modules, either with the Grasshopper interface using Firefly or directly in programming in Arduino, looking also at different sensors such as noise or proximity or light sensitivity. This was followed up by creating 3 groups. One group looked at audio sensors as inputs, as you can see here. First initial tests to propagate sound into motion using the system. And then they were asked to do a small installation. Each group had 4 modules to interactively play with. And you can see as the gong sound comes, those blades or modules open or close up. Another group looked at the proximity sensor, looking at distance to create kind of an intuitive play with the modules. As you can see, the nearer you go to these modules, the more frantic they seem to move, and this was actually a very nice interaction, as you can see, always laughing as those modules are getting more and more frantic the closer you get to them. The last group was looking at brightness sensors, as you can see here. they were programming everything and testing out those intricate circuits and figuring out a mechanism to then control them by brightness censoring. So you can see that they also included LED lights, and the idea was here, if you obstruct that sensor, the modules would move very, very slowly in a very nice sine curve pattern, if you will. And LED lights would be frantically giving you inputs of the movement. And in a collective effort, we then assembled all of the 12 modules and applied each of the 3 strategies to look how it would look in a larger context. The great benefit here was that we could update our online course on our learnings in this workshop and optimize the course even more for future groups to learn from it. And actually this has been already tested with a new set of master students which could build on the knowledge on this online course and actually come up with completely new, more advanced ideas of how to create intuitive human-machine interactions. And the idea here is that we keep on building this platform and feeding them with online courses geared towards human-machine interactions, but also robotics and just basic computational design methods to let our students evolve in a very new and modern way of learning, which is, of course, e-learning and on-demand and decentralized. So I hope this gives you a good overview of this paper, and everything is more profoundly described in the paper, and I would be very, very happy to get in contact with you. So please just write me an email if you have any questions. Otherwise, thank you very much.